Hey guys, this is Module 2, Lecture 1, about population and the environment. So the question I guess we're examining today is this adorable little person the environment's number one enemy? It's a contentious issue, it has been for a long time, and there's a lot of misconceptions out there. So let's see what we can do to clear those up. I wanted to summarize, actually, and tell you sort of the bottom line before I get there, because I'm not always sure. It's kind of a complex topic. I'm not always sure whether I am going to get there. I will eventually, but it takes a while. But the bottom line message is, one, some people see population growth as, again, the number one environmental problem. Number two, consumption, though, my number two here is that consumption is how much stuff are we all using, buying, using, throwing away, etc. A lot of people argue that consumption is actually a bigger issue, and that in any case, population growth is actually slowing down dramatically, which is true. And if we want to see it slow down even more, the best way to do that is to make positive social changes. So what do we mean by that? I'll get to it. But as I said, this is a really contentious issue that's been around for a long time. And if you ask the question, what is the best news for the environment in the last 50, 60 years or so, from the time when people were publishing books like The Population Bomb, which is going to destroy the planet and the global ecology and human beings and everything that we know, etc. What's changed since then? At the time, late 60s, early 70s, sort of the dawning of the modern environmental era, people predicted with great confidence that population growth would be the, basically ecological, planetary, human destruction. And what's happened in the meantime, actually, is not quite what was predicted. In fact, what it's looking like now is actually just around the time that books like The Population Bomb were published, the rate of growth of human population actually dramatically started declining from about 2.1% in 1968 down to, let's see, what would this be? Less than half of that by in recent years. And the population growth is actually expected to stabilize sometime in this century, possibly by the middle of the century and certainly by the end of the century. So that's gigantic good news, no question about it. And if you think of it in terms of not the rate of growth, but the number of people being added to the planet, what you see is these are actually pretty conservative numbers here, that by about 2080, 2090, we'll get to zero people being added, net numbers. That is births minus deaths. That deaths will actually possibly outpace births, and the world's population will begin to decline sometime in the second half of the current century. So that's great news in terms of, if you're concerned about population growth and you think it is an environmental problem, well, it's a lot less of an environmental problem now, and it's going to become less for sure. We know that from demographic data, which are pretty robust. So why is that? Well, again, it's just about as simple as you can get. It's math that even I can handle. It's just births minus deaths is the rate of growth of the world's population. So obviously, when births exceed deaths, then population grows. When deaths exceed births, then population declines. And the death rate really hasn't changed much in recent years. It went it went up a bit in the COVID period. It's probably stabilized again now. The U.S. is a very odd country for a developed country. Death rates have gone up a little bit, but mostly they're actually stable. What's really changed is birth rates, and these data here, this graphic here, should be the best news that you've ever seen in a graphic on a computer. Which basically what this is, excuse me, this is called the fertility rate, which is just a demographic measure of the number of children that the average woman has in her lifetime. As you see from, this is globally, from the middle of the 20th century to the present, the fertility rate has dropped from 5 down to about 2.3 something around here, which is, it's dropped more than half. That's gigantic good news, and if that trend continues, almost certainly we'll get to 2.1, which is what's called replacement level fertility, which the 0.1 is just a statistical measure of the number of children who don't survive until adulthood. So if you get to 2.1, then the population has to eventually stabilize, and so that is really great news. Actually, I'm going to go to this graphic, this text here first, and mention that the growth rates are declining less in the developed countries because growth rates already dropped, and where we're seeing actually the most decline is in the developing regions. Those, places like China, which India just replaced China as the world's largest population, which means that China's birth rate has dropped really significantly. So what we see is a world where every place is seeing declining fertility rates, but most dramatically in the less developed countries, again, only because the more developed countries, the wealthier countries, already saw that decline earlier. And what's really, really encouraging about this is that it's happening in every region. Europe, North America, Latin America, Asia, and even Africa, which has been sort of a demographic outlier for a long time, was considered to be sort of where a lot of the world's population growth was likely to be happening. And so you're seeing that same decline even in Africa, sub-Saharan Africa in particular, which is just fantastically great news from a demographic and ecological human perspective in just so many ways. And what's amazing about it is it's happening in places that you really wouldn't expect it. This is a graphic of Bangladesh. From, again, the middle of the 20th century to the present, you saw a decline from 6 to about 2. And so, that means population's basically stabilized in Bangladesh, which is really exceptional because Bangladesh is a very poor country. And so if Bangladesh can do it, pretty much any place, I think, can do it. And part of the story, a big part of the story here, is that Bangladesh went out of its way to try to encourage smaller family sizes. So it wasn't just an accident. You're also seeing this in various places in sub-Saharan Africa, including, for example, Botswana here below 3 children per woman in her lifetime. So that's really a remarkably good news. And this overall pattern of decline is just what you want to see. And in terms of global scale, again, replacement level fertility is 2.1. That is likely to be achieved, according to this graphic, by, let's say, 2070, something like that. So that's, again, sometime in the middle of the second half of the 21st century, we're going to see that the world's population stabilized. Now, at exactly what level, we don't know. Some of the more conservative projections estimate it might be 10.4 billion. Some projections actually think that it's going to be more like 9 or even 8 billion. We're currently at just over 8 billion. And so, it depends a lot on what happens in terms of fertility rate, and we'll come back to that. What actually makes the difference in terms of declining fertility rates. But we know that at some point in the second half of the 21st century, population is going to stabilize. At, again, exactly what number we don't know for sure. And again, this is just a graphic showing that most of that increase is going to happen of the continued increase is going to happen in Asia and Africa, with the portion that's happening in Asia declining, and that's largely because of growth rates, fertility rates declining in China in particular, but other Asian countries as well. So you see, in most of the world, population is pretty darn either stable or declining, and that's really great news. These are graphics of population projections for the United States, France, Italy, Japan, and what you can see in all of these cases is that population is pretty much stable. In the U.S. and France in this example. Wait a minute, is that right? Yeah, France. Just very, very small increases. Italy and Japan both seeing decreases in population, and that is happening in much of the world as well. So again, if you're concerned about population growth for environmental reasons or other reasons, that's things seem to be going in the direction that we want them to go, right? But why is it, back up, getting ahead of my slides, but why is it that some countries are still seeing a lot of population growth? Well, it has to do with something that demographers call the demographic transition. And in this graphic, what you see is from over time, and this is a model of demographic change that we've seen over and over again in various parts of the world. What you see, and it happened first in Great Britain and Western Europe, but then it happened in North America and parts of Latin America as well, Asia, parts of Asia as well, Japan in particular. What you saw was that as countries became more economically and socially advanced, people had more nutrition, better education, better hygiene, better public health, health services, and so on. What we saw was that the death rates began to decrease dramatically. And because of sort of cultural and social reasons, people's choice was still to have relatively large family sizes, but then they realized that, well, hey, if we're going and working in an office instead of working on the farm, it doesn't make a ton of sense to have 8 children or whatever. So they started having smaller family sizes as societies industrialized, and so eventually the decline in birth rates catches up with the decline in death rates, and you get to a position of population stabilization. And what's happening in the less developed countries right now is that they're actually passing through this stage, going from a high mortality, high fertility regime, lots of children being born, unfortunately lots of children dying, and so on, to a condition where you have fewer children being born, but also a lot more surviving, and with population stabilized. There's two kinds of population stability: high fertility, high mortality, or low fertility, low mortality, and obviously you want the latter and not the former. But in the process of that transition, there's a period when populations grow a lot. And what we know is that the European societies, North America, Japan, etc., went through that process, and other societies almost assuredly will go through the same process. How fast is a key question, right? And that question of how fast and how much fertility drops is a really key question in terms of population projections. Depending on what sort of projections you have, sort of the optimistic projections where you end up with a growth pattern that actually a population change pattern that actually results in declining populations by the end of the 21st century, or continued high rates of population growth, depends on what happens with fertility rates. So small differences in fertility lead to really different sorts of outcomes in terms of population. And high fertility is, remember when I talked about people writing books in the late 1960s about the population bomb and so on, it was kind of assumed that fertility was just kind of baked into human nature. People had a certain number of children, it was just, biological or whatever, and that wouldn't change much. It turns out that's not true at all. It turns out that as social conditions change, people tend to have a lot fewer children. As people move from rural agricultural societies into urban and industrial societies without really doing anything, no coercion, population control needed. You see transitions to much smaller family sizes, right? It turns out, those assumptions about fertility rates being kind of stuck and unchangeable were just plain wrong. The key question is, what sorts of social conditions enable people to make choices to have smaller family sizes? One thing I want to mention here that's really important is that, again, back in the 1960s and 70s, people were talking about a lot about population control, and you still hear that in some environmentalist circles. We need to have population control. I'm kind of like, well, have you not actually read the demographic data for the last 60 years or so? Because for one thing, the trends are already going the way you want them to go. So whatever it is that's working, and we'll get to that in a minute, we should do more of that. And it turns out that some countries were so alarmed, India is a prominent example, some countries were so alarmed that they used coercive population control, forced both women and men actually to have be involuntarily sterilized, which was it was brutal. It resulted in all kinds of human rights abuses and so on, and it didn't work. India today has the world's biggest population and is growing among the fastest countries in the world. So what happens? That begs the question of what works, what really matters in terms of affecting people's choices about how many children to have. The answer is things like economic security. If people live in largely agricultural societies, more little hands means more people to work on the farm. Or if the only source of jobs in your community is working in this case on a tobacco plantation in Indonesia, and you have a lot of kids and they're not going to school because they can't afford school fees or uniforms or whatever it is, they can go work on the plantation and make some money and bring it home. Turns out that little hands actually are really good at doing things like picking and sorting tobacco and so on. In certain kinds of less developed economies, it just makes a lot of sense for families to have large numbers of children. But those are typically conditions when people live in poverty with very little economic security and so on. So when people get jobs, wage labor jobs where they're protected by laws and unions and so on, and they have more economic security, they have a lot fewer children. That's just been shown over and over. And things like healthcare. You would think that, well, if you have more healthcare and more children survive to adulthood, then you would actually have a larger population. It turns out that it's exactly the opposite. That if you give people adequate healthcare, the parents choose to have smaller family sizes, knowing that a larger number of children will survive to adulthood. So if children have inoculations, access to prenatal care, postnatal, nutrition programs and so on that enable families to make sure their children survive, they'll have smaller family sizes. Because it's kind of grim to say this, but families in many societies where they don't think the children will survive will have sort of a larger number, knowing that, and in a sense, sort of overcompensating. Education is overwhelmingly the most strongly correlated factor with smaller family sizes. I won't go through this whole table, but it's just an interesting example in Ethiopia. At this top chart here, what you see is that girls in this case who have access to education, or let's look at this one first, girls who do not have a secondary or higher education level, secondary school or higher education level, have about 6.1, this is a little bit out of date data, but about 6.1 children, compared to girls who do have a secondary school or higher education have about 2 children. So a factor of 3, that's a huge difference. Why does that make sense? Well, if women have opportunities, can go out into the workforce and be autonomous, lead their own lives, make their own decisions through education, then they tend to have a lot smaller family sizes. It makes sense, right? And culture, things like, in this case, age at marriage. In places like Niger and West Africa, what you see is that the typical or average age at marriage is about 17 years, something like that, compared to Sweden, where it's, let's see, where are we, 2017. So these are a little bit out of date data, but Sweden compared to Niger, is, let's see, average age at birth in Sweden is, looks like roughly 35. And you can just think about that for a minute and think about, okay, well, if, sort of the window of childbearing years is up to, the early or mid 40s, then Swedish women will have a much narrower sort of period when they are likely to be having children after marriage, and that results in smaller family sizes. And sure enough, that's exactly what happens. And so culture is really important. Things like when girls are expected to be married make a really big difference. And what we see time and time again is that in patriarchal societies where girls don't get to choose their age at marriage, you see larger family sizes. Where girls do have autonomy, where patriarchal cultures aren't dominant, girls will choose typically to have smaller family sizes than their male partners. We've seen that all over the world. So women's autonomy and empowerment as parts of culture are a really key part of the story of declining fertility rates. Let me sum this up. In 1982, a demographer named John Caldwell sort of formalized what I was just talking about under what he referred to as wealth flows theory. And what that means is that it's basically sort of a cost-benefit analysis that you do about having children. It's basically if children cost the parents more, then they'll have fewer children. It's sort of, you kind of hate to think of children as an economic asset, but it's the reality that parents anywhere have to face. Whereas if children, I mentioned, showed you the example of, girls working on a tobacco plantation in Indonesia. If those children provide more money sort of flowing upward from the children to the parents, then the children are an economic asset, and the parents go, yeah, we want more children. I mean, you hate to think of it in those terms, but people do think in terms of sort of the economics of how many children to have. It's just, it's unavoidable. Gender equality, which I just talked about, women's autonomy, allowing later age at birth, allowing girls to choose to be married at later ages, and so on. Educational opportunities and income and employment. Urbanization is a key factor. If you live in a crowded city and space is scarce. If if you had a family of 8, where are you going to put them? That becomes, those sorts of practical questions become real decisive variables in terms of fertility. Survival and healthcare that I talked about before. Old age security, something I didn't talk so much about, but in a lot of societies where parents don't have retirement plan or social security income, those sorts of social institutions for old age, the only source of support that they have in old age is their own children. And so if you provide social security and retirement benefits and so on for older adults, they'll say, hey, we don't have to sort of invest in our 401k children plan of having like 8 children. They say, hey, we'll be okay in old age. We don't need to have that many children. One last thing I want to add here, which is the role of contraceptives, which has been very sort of contentious over the years. And it is part of the story. There is such a thing as, an accidental child, births that weren't intended, more than the parents wanted. But for the most part, what demographers find is that families have the number of children that they intend to have. They have the number of children that they want, give or take, right? And so contraceptives can be a valuable part of family planning efforts, but the key thing is the family has to want to have a smaller family size, or they're not going to use the contraceptives. And I've worked in the past a lot in places like sub-Saharan Africa, where people are just not particularly interested, to the great frustration of outside development organizations, often just not particularly interested in contraceptives because they, the social conditions, education, gender equality, etc., that enable people to want to have smaller family sizes aren't in place in some of those societies. So again, contraceptives can be helpful, but are not the key factors, frankly, in terms of fertility decline. Again, the social conditions have to be in place to make families want to have smaller numbers of children in the household. So in terms of thinking about proximate and root causes that we talked about last week, if you ask the question, well, where does population growth even come from? Well, we just talked about it. It comes from poverty, it comes from gender inequality, it comes from lack of adequate health care, it comes from old age insecurity, lack of education and job opportunities, and so on. And if you flip that around and ask the question of what are the root causes of population stabilization, population stability, well, they're the flip side of those. You don't need population control if what you have is you have contraceptives, but most importantly, you have development, gender equality, health and education, healthcare and systems that help children to survive to adulthood, old age security, education, and job opportunities. If those things exist, then families will use the contraceptives and want to have smaller family sizes. It's just been shown over and over again. So to achieve population stability, you ought to do what works. We know these things work. Gender equality, educational and job opportunities, especially for girls and young women, healthcare, and so on. Those things work. They make the difference. That's why those graphs are trending down the way we want to see them. For example, childhood mortality has been declining consistently for decades now. That is just great news. When more children survive, families make the choice to have smaller numbers of children. So, moving to, this is sort of a second part of today's lecture. which is population growth. Okay, so what we know is population is still growing, but it's growing more slowly, and it's predicted to stabilize sometime in the second half of the 20th century. This is all great news. So is population growth even an environmental problem? Well, there are some reasons I think you would have to say maybe not. To the extent the population is still growing, maybe it's not really even the main thing that we should be focusing on. To give you a sense of that, 17% of the world's wealthiest people, that is, people in the United States, Western Europe, Japan, Singapore, wealthy countries in the world, consume about 80%, and this is a small portion of the world's population, 17%, consume 80% of the world's resources, which leaves the other 6.7% of the world's, 6.7 billion people on the planet living on the remaining 20%. That's huge inequality. And what you see that in this graphic, you see that in red here, for example, the United States, with about 4% of the world's population, shows up on this graphic really, really big. It's graphing consumption, ecological consumption from the world's natural resources, and creation of pollution and so on. And you compare that to Africa in this example, and you see the entire continent geographically, in terms of square miles, the United States would fit into the continent of Africa many times over. But on this graphic of consumption, what you see is the United States is many times bigger than the entire continent of Africa, which represents the fact that the U.S. Has extraordinarily high consumption rates. And what you see in this graphic also is that that's characteristic of Western Europe and some parts of Asia as well. And this is a quote that I'm struck by an economist named Fred Pierce, an environmental economist, and we'll talk about environmental economics next time, made the observation that the carbon emissions of one American today are equivalent to those of around 4 Chinese, 20 Indians, 40 Nigerians, or 250 Ethiopians. And Fred Pierce goes on and says, "How dare rich world greens blame the poor for the planet's perils?" And he's right. When you look at this graphic, you go, okay, where are the poorest places in the world? Well, they're in sub-Saharan Africa, and they're in South Asia, parts of Southeast Asia. And what you see is that those parts of the world really have relatively very little impact. And keep in mind, where's the world's fastest rates of population growth? Africa and parts of Asia, right? But they're having very little overall impact on the world's overall consumption, and also greenhouse gas emissions, for example. Again, if the United States was mapped by population size, this is what you would see. But if you map the U.S. map the world by greenhouse gas emissions, the United States expands like this, and Africa shrinks down to almost a non-entity on the map. And that's because the world's richest countries and the world's richest people within the world's richest countries cause vastly more CO2 emissions than everybody else. The world's richest people in this headline cause twice as much CO2 emissions as all of the world's poorest people. All of the 50% of the world's poorest people. So that is, say that again. The world's 1%, richest 1%, cause twice as much CO2 emission as all of the poorest 50% in the world. So that's, today's population is about 8 billion people. So, and that I would have to do the math, whatever that number is. But 1% of 8 billion is a pretty small number. compared to 4 billion people, and that 1% is producing twice as much CO2. That's just, that's a huge inequality. And again, those richest 1%, they live in countries where population is either stable or actually declining. So can you say that population growth is causing, in this case, climate change? It would be a tough case to make, for sure. Take a look at this graphic. In this case, it graphs carbon emissions per capita, that is per person. And you look at the US here, very high levels of per capita, per person CO2 emissions compared, for example, to sub-Saharan Africa. Here's a similar graphic about the total accumulated CO2 emissions and other greenhouse gases in the atmosphere. Number one is the US, followed by China, Russia, Germany, UK, Japan, India, France, Canada, and Africa wouldn't even be on this map. Much of South Asia wouldn't be on this map at all, because their contributions overall to greenhouse gas emissions are so small that you wouldn't even be able to show them on the graphic. Okay, so where does that leave us in terms of thinking about the role of population in the world's environmental problems? Should we just ignore population? I would say no. But is it what you should emphasize? I would say no, because of what we just talked about, which is that the world's largest populations are not where most of the impact is happening. Now, impact is shown in this graphic here. This is a very famous identity, the I equals PAT identity. And what it says is that the world's environmental impact is some sort of relationship between population growth, affluence, which you can also call consumption, and technology. So is population the P part of this identity? Is that unimportant? No. But it has also to do at least as much with questions like how much stuff are people consuming, and which people are consuming stuff in which parts of the world, and also what sorts of technology are they using. Are they using green energy, or are they using fossil fuels? That makes obviously a really big difference. Well, let's think about this I equals PAT equation a little bit more, and I'll go through the P population and the T part briefly, and then I'll focus on the A part in the middle there. Population growth. Again, like I said at the beginning of this lecture, there are people who say it's the number one environmental problem. People have been saying that for a long time. It's just sort of, the most simple imaginable arithmetic. More people consuming more stuff leads to increased environmental impacts and planetary destruction, etc. And that's assuming a couple of things. One, that population just keeps going up, and that the places where population keeps going up are the places where stuff is being consumed and the most pollution is being produced, and so on. Neither of those turn out to be actually true for the most part. But that was the thinking. Thomas Malthus, economist in England in the late 18th century, made this argument that's basically that population growth is the root cause of environmental problems, and that kind of thinking has been very sort of stuck in place for now a couple hundred years or so. There are other folks who actually make sort of an opposite argument and argue that technology, the T part of the I equals PAT identity, actually stimulates scarcity, which drives up prices of commodities. And for example, fuel prices have gone up a lot, and that stimulates investment in greener technologies, which actually brings down the ecological impact of population or affluence. And there's something to be said for that, for sure. We've seen gas prices go up a lot, and it's not just coincidental that at the same time we've seen, the advancement of renewable energy. Renewable energy is by far the largest and fastest growing sector of the economy in the world today. The European Union just recently saw a transition in which now more energy in the European Union is produced by renewables than by fossil fuels, which is really great news. And that leads to less environmental impact. But there are other folks out there who say, well, is it always that sort of a happy story? Not necessarily. This guy named Barry Commoner, an ecologist, again from the 1970s or so, who argued that, well, it depends on what kinds of technological change you have. And Commoner said, we've compiled a record of serious failures in recent technological encounters with the environment. In each case, the new technology is brought into use before the ultimate hazards were known, and we've been quick to reap the benefits and slow to comprehend the costs. And Commoner was probably thinking here about things like pesticide poisoning and other toxic chemicals. And I think it's also true that as people have become wealthier and as populations have increased, people have used some bad technologies, environmentally harmful, and harmful technologies that harm human health as well. So, is technology either good or bad? The answer is yes, it's both. It depends on what particular technology you're talking about. So go back for a minute to this. So is technology in this case a good or a bad thing? The answer is it depends, and it's kind of hard to know. Are we going to have more advancement in renewable energy, or are we going to have more use of toxic pesticides and so on? The answer can clearly be both. So is technology in the I equals Pat equation or identity good or bad? The answer is both. What I want to emphasize now is I want to talk about the A part of the I equals Pat identity, affluence, and emphasize that numbers. Affluence, again, is basically another way of saying consumption. Consumption is not just a matter of numbers. It's a matter of lifestyles. Here's Mahatma Gandhi, the independence leader of India, who fought the British successfully and did so partly by refusing to consume consumer products produced in Great Britain, much to the dismay and chagrin of British colonial rulers. And Gandhi was successful and actually made a kind of low consumption lifestyle into a political tool for empowerment and liberation of what became independent India. And Mahatma Gandhi very famously, his entire worldly possessions consisted of a few pieces of cloth to cover himself, a pair of eyeglasses, a walking stick, and a copy of the Bhagavad Gita, and that was about it, right? And then you compare that, say, to this is Russian oligarch, billionaire Roman Abramovich, if you've ever heard of him. He used to be, those of you who follow soccer might know that he used to own the Chelsea football club in Great Britain, and owns two of the world's largest yachts, including this one, which is actually, I've seen more recent numbers that show that it's worth more than $1 billion. It's got things like an underwater submarine docking port so that he can get on and off a ship without the peasants ever actually seeing him. And these, I mean, I think you're getting the point here, right? You compare that lifestyle to this lifestyle. Which one has a larger ecological footprint? Well, I'm picking on Russian oligarchs here because, frankly, they deserve to be picked on. But it's not just Russians, it's the world as well. I mean, the United States, there are plenty of billionaires and so on I could have picked, but again, the Russians kind of deserve it but right now. But think about the U.S. as well. Think about our houses. We have some of the biggest houses in the world. On this graphic here, the U.S. only behind Australia in terms of the sort of square footage of houses. Houses keep getting bigger, even while the per household family size has gotten smaller and smaller. So, family size is just a little over 2 people in the household, and yet the houses have been getting bigger and bigger. And so it's smaller numbers of people living in bigger and bigger houses, and you can see the ecological consequences of that. More materials, more energy, and so on going into housing a smaller number of people. You compare that, for example, to Bangladesh, where the average household size is typically somewhere between 5 and 10 people, and the US, where it's about 2.5 people, and yet Americans live in much bigger houses. And you ask the question, who exactly is having the greater ecological impact here in the I equals Pat equation? Well, it has a lot to do with not just the question of affluence, but how that affluence is distributed. And also the population question comes back to a question of, okay, is population growing more in Bangladesh? Well, we just learned actually population is basically stable in Bangladesh. And it's stable in the U.S. too. But the U.S., in this case, is consuming a lot more stuff per person. So the population part of the story kind of just drops out altogether in that story, which is what I'm saying here. And then one footnote I want to make, and obviously this is a big complex topic. There's a lot to be said here that I'm leaving unsaid because it is a big complex topic. So I'm oversimplifying. There are lots of cases where I think you can make a very persuasive argument that localized population growth has had significant impacts. This is the case in Brazil, where for political reasons, for generations now, decades, we've seen Brazilian leaders sending poor people from urban slums out into the Brazilian Amazon because of political reasons, basically. Unhappy people living in urban slums creates political instability. And Brazilian leaders have been recognizing that for a long time, has been sending people out into the Brazilian Amazon, where the first thing they do is they want to plant a farm, and they have to cut down the forest to do that. But it turns out that fertility in Brazil, like other parts of the world, is going down dramatically, and that the population of Brazil is almost certainly to decline within the century. So again, is population part of the story? It is for sure, but certainly not the biggest story right now. And also, a key question that you have to ask is where exactly in this example are the agricultural products that are being produced by those people moving out into the Brazilian Amazon being consumed? Remember, consumption is at least as important a part of the story here as population. And the answer to that is that the soybeans or the cows, etc., that are being produced in the Brazilian Amazon are largely, not exclusively, but largely being consumed outside of Brazil or by wealthy people within Brazilian society itself. So again, is population part of the story? Sure, absolutely. Is it the main story? That's debatable, for sure. Where I want to leave things is thinking again about this question of affluence, is that the inequality of wealth across the globe, and which we'll talk more and more about throughout this course, is creating a pattern. It's kind of inequality of wealth at the way A in the I equals Pat identity is distributed is very unequal. And what that's leading to in some parts of the world is very high ecological impact, but through a couple of different kinds of processes in different parts of the world. In the high consumption countries, in the rich countries, you see a different pattern than in the underdeveloped or the poorer countries, where in the in the less developed countries, what you see is high fertility that's driven by underdevelopment, lack of access to jobs, healthcare, education, gender equality issues, and so on. And compare that to the high-income countries where you're seeing large ecological impact, predominantly through high rates of consumption. So the inequality of wealth globally is producing this sort of bifurcated pattern of high consumption in the rich countries that are growing the least in terms of population, and high fertility rates and underdevelopment in the poorer countries, which are at least in part, the high fertility rates are at least in part a result of the inequality of wealth distribution, the persistence of poverty in some parts of the world. So that inequality of wealth distribution across the globe is contributing to ecological impacts both directly through consumption in the wealthy countries and indirectly through continued high fertility in the poorer countries. So if you want to solve both of those problems, you can reduce inequality and simultaneously reduce population growth in the less developed countries and environmental impact in the wealthy, industrialized countries. So let's go back to this question of is population an environmental problem? Well, if only 17% of the world's population is consuming the great majority of the world's resources, what does that say about the impact of population growth? I think what it says pretty clearly is that most of the world's population growth, again, is happening in the places in the world where there's relatively little environmental impact. So you can have a lot of population growth in sub-Saharan Africa with relatively little global scale ecological impact. And at the same time, in the wealthy countries, you're seeing most of the world's ecological impact is actually happening originating from those places where there's really very little population growth. So again, is population growth part of the story? Yeah, but it just doesn't seem like it's really the main story. So was Malthus right or wrong? The answer was he was wrong. And I think you can blame the conditions that we're facing now. Certainly, I showed you those graphs of accumulated greenhouse gas emissions. You can blame it a lot more on the wealthy countries, and including Russian billionaires and so on, than you can on people in India or sub-Saharan Africa and places like that. And so I think you can say that population is part of the story, but it's very heavily mediated by what's going on in society, including in particular, how wealth is distributed. So just to summarize, the world's biggest environmental problems are not driven mainly by population growth. They are, I think, demonstrably the world's biggest environmental problem is global climate change, obviously being the primary example. Consumption is a bigger part of the problem. I think that's very clear. And I think you have to say in terms of consumption, the inequality of consumption or the inequality of wealth or affluence drives both high levels of consumption in the rich countries and continued population growth in the poor countries. And to reduce environmental impacts if you remain concerned about population growth and you want to reduce population growth and its environmental impacts, then you should focus on things like providing healthcare and education to girls and young women in poor countries. But you should especially focus on reducing excessive consumption in the rich countries. I got those bullets a little bit backwards, but you get the point. So if you see population as an environmental problem, you can focus on questions like healthcare, education, gender equality, and so on. But you should really look at where most of the impact is actually happening, and it's not in poor countries where population is growing. It's largely us living in the wealthy countries where population is not growing at all, or in many cases, like Western Europe and Japan and so on, actually declining. So is population growth the number one environmental problem? I would challenge anyone to support that claim. Okay, I'm going to leave it there. Yeah, that's my last slide. I'm going to leave it there. And next time we'll be talking about environmental economics, which to some extent sort of overlaps with our conversation last week about the so-called tragedy of the commons, more correctly described as the tragedy of open access, and in interesting ways actually overlaps with the population conversation we just had. So I look forward to seeing you all then.